Dear Patil sir, you may please start, sir.
Okay, thank you, sir. Am I audible? Hello.
Yes, sir, you are audible.
Yes, audible. Okay. So first of all, I welcome all the participants and our today's expert, Mr. Raj Hakani, sir. So I introduce sir here. So Mr. Raj Hakani is an accomplished academician, researcher, and innovation mentor specializing in drones, wireless communication, and robotics. He currently serves as an assistant professor at Gujarat Technological University, where he leads initiatives such as Design Innovation Center, ASC funded Idea Lab, Robotics and Automobile Clubs, and SSIP Mentorship Program. He is a DGCA approved drone pilot and is pursuing his PhD in drone technology at Institute of Infrastructure Technology Research and Management. With a strong academic foundation, including an MTech in Electronics and Communication Engineering from Nirma University and B in the same discipline. Mr. Hakani has qualified the GATE examination with high percentile, guided numerous UG and PG students, published multiple research papers in national and international journals, and serves as a reviewer for several reputed journals. With expertise spanning antennas, wireless communication system, robotics, innovation, and startup mentoring. He brings rich interdisciplinary insight as an expert speaker in emerging technologies and drone-based application. So I request our today's expert now with this particular introduction, you may start our today's presentation. Thank you, sir.
Thank you, sir. Sir, shall I share my screen?
Yes, sir, you
Yes,
can
sir.
share your screen.
Yes, sir, you can.
Sir, actually, I don't have any access to share my screen.
Sir, I have allowed all the permissions as a presenter for your ID.
Yes, actually, there is a
Share.
yes, sir, there is share options, but only meeting organizer and presenter can share. That is message is showing.
Okay, just a minute, sir. I will make you
Two
the
devices.
presenter once again. You are on two devices. Just a minute, sir.
Yes, sir.
Sir, requesting you to kindly try sharing. Raj, sir.
Hello.
Hi, yes, sir. Are you able to share the screen now?
No, sir. Actually, still I'm not able to share the screen because option is not available. I also left the meeting and rejoined the meeting, but option is not available. Actually, my presenting screen that will be a Raj Hakani underscore GTU. So I'm presenting from my laptop and my audio will be coming from my mobile phone.
Mogul sir, please check. Two IDs are there.
स्क्रीन शेयर में ऑप्शन नहीं होता है यहाँ पर. नहीं पा.
Only meeting only.
हाँ, but actually ये लोग को मैंने rights आते हैं सर. Sir, actually you have give me the rights on the Raj Hakani. Actually, you have to give the rights on the Raj Hakani underscore GTU. Hello.
Yes, sir. Just a second, sir.
Yeah.
Okay, now you can check, sir.
Yeah, sir.
Yes, sir. It's visible now.
Yeah, it's visible, right?
Yes, yes.
Okay, okay. So shall I start?
Yes, sir. You can continue.
Okay. So, thank you, Praveen sir and Vaibhav sir, to introducing me. The FDP topic is integrating the AI and ML for the sustainable electric vehicle development and the smart mobility. And the session topic is that autonomous and connected electric vehicle, the role of the AI. So in the today's presentations, I will cover the some of the things. What is the smart mobility? What is the mobility? So I think that will be already covered in the previous session, but the overlook I will cover it. What is the importance of the AI into the electric vehicle, and how we can implement the AI into the electric vehicle, and how we can connect the all the things together and design a complete system. So basically, so first of all, why the smart mobility needs the AI? So first of all, we can understand about the what is the mobility. So mobility can refer as a movement of the people and the good into the safe environment, efficient, accessible, as well as a sustainable manner using the various transportation system. So mobility is not a vehicle type of the problem, but it a problem of the system. So we can understand through this particular slide. You can see in the first figure that will be the in your slide. We can put up the three figures so we can understand the three figures one by one. The first figure you can see here that will be a traffic congested. So in this particular figure, you can see the number of the vehicles is available. The people is also available. The bus will be also available. So number of the vehicle will be available, but it might be possible that they are the electric vehicles. But we cannot control the traffic. If all vehicles that will be electrical vehicles. Yes. Hello. Hello. Okay. So we cannot control the traffic using if all the vehicles are the electrical vehicles. Now in the second figure, that will be a multimodal transportation system. So people are using the multi-mode transportation to travel from one place to the another place. They can travel through the walk. They can use the bus, metro, or their particular own vehicle, like a auto or the bike or the bicycle. But we can assume that if all are electric vehicle, but that will be a system level of the problem, not the vehicle level problem, because assume that if all the vehicle are traveling on the same time, same road, so the traffic will be congested and we cannot control the particular traffic. So using the AI, we can control the traffic as well as we can control the schedule time, in particular which schedule the particular vehicle should be a travel on the road. So in the third figure, that will be a smart city type of the mobility ecosystem. In that particular system, you can see that the traffic camera is already available, EV charging stations are available, control centers are available, as well as the cloud platform is available into the city. But this is also the same type key. This particular is not a vehicle type of the problem, but they are not an isolated type of the machines. But this is, we can consider that will be a node inside the digital system network, which can be controlled using the artificial intelligence. So we can go with the next slide. So currently, what mobility challenge we are facing? So right now we are facing the four major points we are facing. First point, that will be a traffic congested. You can see in the into the figure. Second, that will be a road accident. Now we can assume that key vehicle are, that will be electric vehicle. But if driver are driving the vehicle, but that will be a careless driving are there. So that will be might be possible ki the accident chances is more. So some of the figures we have captured into the figure, the figure that will be taken from the Times of India, and figure that will be taken in the not recent figure, but the figure counting that will be in the 2024 December 2024 figures are there. 90% of the accidents are occur due to the human errors, which can be resolved with the help of the AI. The third problem, that will be energy inefficiency. So right now we can convert it all the vehicle into the electric vehicle. So we can control the energy or the fuel type of the efficiency and can resolve this particular problem. But using the AI, we cannot control or we can resolve the problem which we are facing into the first two parameters, that will be a traffic congested as well as the road accident. The third figure, that will be a pollution as well as the emissions. So right now, EV vehicles are available, but not the 100% EV vehicles are available. So based on the carbon emissions and the polluted gas, the air there will be a polluted and we cannot control. But we can control or we can measure the AQI with the help of the AI, and based on that we can control the number of the vehicles if the vehicle are not vehicle are making the more pollutions, right? So based on that, we can control or we can measure using the or with the help of the AI. So this will be the despite of the better vehicle, the whiter road condition. Right now, what we are doing, we are taking care or we are looking only on the, we are developing the better vehicle, which cannot produce more pollutions, which can be a EV, or we are developing the construction sites more, but we are not taken care by the why the accidents are happened and what are the reasons the accident that will be happen. We are not controlling the traffic, we are not controlling the, or we are not scheduling the time of the particular vehicle. So at that particular time, the AI that should be into the picture, we need a AI into the electric mobility. Third thing, we are trying to solve this, but we are not, but still the problems are the same or as it is. So current mobility challenge, can the AI, can the EV stand alone, can solve this type of the problem? Can anyone answer? अकेले AI के साथ हम ये सारी प्रॉब्लम को सॉल्व कर सकते हैं? No. So this particular way, we need artificial intelligence or the machine learning. We should combine the EV as well as the AI or the machine learning with the AI. So why the autonomy and connectivity is required? So in this particular figures, that will be two type of the figures. You can see the figure, and the combination we mentioned into the figure number 3. I'm audible? Hello.
Yes, you can continue.
Okay. So what we can include into the autonomous vehicle, or we can measure into the autonomy. We can sense, we can decide, and we have to act. But into the, if we are talking about the, we are taking the case study of about the vehicle. So how the vehicle can sense the nearby the traffic, how it can sense the distance between the two vehicles, that will be a proper or not. Based on that, it can transmit the command to the particular controller, which can give some actions to the steering, or that can be a give to the command to our accelerator, and based on that we can control the vehicle. Now we are talking about the connectivity part. The connectivity part, that will be divided into the three part, that will be vehicle to vehicle, vehicle to the infrastructure, as well as vehicle to the cloud. Two vehicles should be connected to the each other. If we are talking about the same problem statement, vehicle to the vehicle, for an example, ki, two vehicles are available and we have mounted the multiple sensors, or we have uh, make the vehicle that will be mounted with the all the autonomy into that particular vehicle. If anything accident that will be happen, it can transmit command to the cloud, it can transmit command to the next by the vehicle, and nearby the we can transmit the command to the end of the level. Same thing vehicle to the infrastructures. Whatever the our vehicle, it can measure the any of the data. It should be transmitted into the warehouse or the data center. It might be possible your vehicle health, your battery management, your vehicle health, vehicle health that will be measured. We can measure into the different parameters. But the battery management is there, the vehicle tire air pressure is there, accelerator will be work properly or not, or it should be connect. It should be transmit the command to the traffic signal. If the traffic signals is green, then we have to travel the, or if the traffic signal is red, then we have to stop it. So autonomy, as well as we have to mention, that will be into the connectivity. So we can also send the data into the cloud. So based on that, this particular both the command, if autonomy and the connectivity, we can combine the whole structures. If, or both the vehicle should be communicated or transmit the command to the each other. We can avoid the collisions, or we can uh, avoid the accident, as well as we can slow or the we can manage the traffic. It should be, if the heavy density is there, then we can control the traffic signal. In the later on the slide, we can do some of the hands-on sessions using the real-time example. So how the AI, the role of the AI into the smart mobility. So in this particular two pictures, we can assume that in the particular vehicle we have mounted the multiple type of the sensors. It can sense the command. What are the surrounding to us? Our rear camera, right now the whatever the vehicles, we have a front camera as well as the back camera. Based on that, we can travel our vehicle. The reverse parking or the front camera is also there. So based on that, we are driving our vehicle. But it can also measure the distance between the two vehicles based on the lidar sensor, based on the other sensors. It can measure the sufficient distance. If the sufficient distance between the two vehicle is not there, so it can give the alert system, or it should be give some command to our brake system. It should be we have to control our vehicle, or we have to slow down our speed of our vehicle. Now, if we are talking about the rear collision, so we have a rear camera, we have a rear sensors for the parking systems. So in that particular way, we can include our artificial intelligence as well as machine learning into the electric vehicle. So now we are moving to the mobility, to the smart mobility. How we can transfer the normal mobility. So normal mobility is moving the one place to the another place. Now we how we can include the smart mobility. So first in the we have a four figure. In the first figure, you can see that that will be electric vehicle, but it should be a clean as well as the energy efficient. We have a sufficient charging stations as well as the well maintained charges. We can also include the mobile app. The, what are the nearby charging stations? If our vehicle battery are small, if we have some of the using the GPS, it can identify our own locations, and it can also detect what are the nearby our charging stations is that. It will be empty or it will be already occupied. What are the chances is there? What are the queue timing is there? So based on that, we can implement the smart mobility or the into the electric vehicle charging station. We are talking about the particularly charging stations. In the second figure, we are talking about the driverless car, or the we can talk about the autonomous without driver car. So in that particular car, it has a multiple sensors based on the front end camera or the lidar sensor. It can detect the what are the distance between the two vehicle. The camera is there, so it can detect if any of the traffic signal is there or not. It can also measure the traffic signatures. If we have to slow down the speed, we have to maintain the speed or not. If we are traveling the same vehicle on the highway, then we have to or we can travel up to the 50, 60 or the 70 kilometer per hour speed. But the same vehicle should be travel into the urban area or into the city area. Our maximum speed of the vehicle, that will be a 40 or the 50. So how we can control the speed of the vehicle? Similar type, we can also measure the battery health as well as our vehicle health. The now the vehicle is a very smarter. We can also measure our fuel tank, that will be an indicator, but we can also measure the our car need a service or not. Basically what we are doing, we are manually decided कि our car should be go to the repair stations, or the we need a maintenance in our car. So we can also put this type of the system in our vehicle, so it can give the particular output. Battery management system is also there. Now we are talking about the third figure, so that will be a connectivity to the vehicle to vehicle as well as vehicle to the data center, or we can call as a vehicle to the infrastructure center. So it can also transmit the data. For an example, another vehicle can measure the accident is happen into the road, so it can it can collect the data and can transmit to the nearby hospital or the emergency vehicle. It can also transmit the data to the particular data center. Based on that, we can take the decisions. Uh, we have to call the ambulance, we have to call to the fire station or not, we have to call to the nearby hospital or not, whatever. So based on that, we can control or we can send the data to the data center, and based on that, we can take the decision. In the third figure, so that will be a data center. So you can see in the particular all the combination of the three figures that will be combined into the figure number 4. If based on the remote places, we can measure the everything. It should be the person has followed the traffic rules or not. Is there any accident is happen or not? And based on that, we can control the traffic. We can inform the any of the emergency vehicle or whatever. We can also measure the remote places. We can measure everything, or we have taken care of everything at the remote places. Okay. So now we are talking about the evolution of the electric vehicle. So in the first figure, you can see that will be a ICE vehicle where the only mechanical or the gear system is there. There is no intelligence, as well as the more polluted system. Later on, we are developing the hybrid vehicle, engine plus the motor or the better efficiency. We are maintain, or that will be a indicator is there. Our student is making the hybrid type of the vehicle. For an example, our student has developed the hybrid vehicle. 90% the vehicle is traveling through the EV vehicle or the electric battery. But assume that if you are traveling at or you are at the remote places where there is no any charging stations, so we have a 1 or 2 liter of the reserve tank of the petrol. Based on that, we can charge our battery and we can travel again using the electric vehicle. So this type of the hybrid vehicle we can also develop, or these are also available into the market. Plug-in type of the hybrid vehicle, so partially electric drive or the charging station, just like a petrol or CNG car. Sometimes we are traveling to the CNG, and if the CNG is empty, then we can switch over to the diesel or the petrol. Now some of the research are ongoing on the better EV vehicle. Some are working on the speed, some are working on the better battery life. It cannot be a particular. We have seen some of the incidents. The battery will be a flammable or the battery will be a blast, right? So we are some of the researchers are working on the battery life. Some are working on the how we can increase the speed. Some are working on the long charging. In the single charge we can travel the more. So based on that, the evaluations or the we are developing the new electric vehicle. Now the smart vehicles we have already developed the driverless car. We can call as a driverless car. The sensor we have mounted, the AI software we have mounted. There is no human interactions is available for the driving the car, right? So in this way, the electric vehicles are evaluations from the basic to the advanced level. We are what are the futures? We cannot talk about that. We can whatever the implementations right now, the blockchain technology is there, artificial intelligence is there. So based on that, we can also now the AI is there, so we have to take care about the cyber security. But we are not talking about that particular part because that will be out of the track. Now, how the EV architectures will be a work. So in this particular figure, you can see that will be a battery life, battery management system. How we can control or how we can manage our battery system. Then the inverter is there and we can send the command to our electric vehicle or to the driving steering or whatever the vehicle we have to travel. So these are the basic architecture. Now we have to talk about where we can implement our AI. So every particular block diagram, we can implement our artificial intelligence or the machine learning algorithm in this particular pictures. Now we are talking about the battery health. So battery health, we can implement our artificial intelligence systems is that if there is some of the battery that will be a drain, then it can give the indication. So we can also measure based on the sensors, but we can also measure through the artificial intelligence. We can also using when or what should be the we can also do this type of the algorithm the battery prediction system. Our battery life is that our vehicle should be traveling or the continuously we are charging and discharging. So how much time will require we should have to or we have to replace our battery, right? So based on the predictions, we can apply this type of the algorithm. In the inverters, we can also implement our algorithm ki how the inverter system will be a work. What we can also measure the parameters. What are the basic or internal parameters is that, right? Accelerometers we can control. What should be the braking system is there. So based on that, we can control our vehicle. Similarly, into the motor health we can measure as well as we can control using the artificial intelligence. So role of the BMS into the energy management. So you can see here key 92% state of the charge health we can measure using the BMS system. So in the BMS system, we have a multiple sensors there. Thermal management, self-balancing is the most important part into the battery. If one of the cell is damaged or that should be below the threshold level, so our battery or our system, the overall system can be a failure. Sometimes if we have to measure our overcharge protections or we can put up a similar type of the sensors if our if the battery is fully charged and still we are plugging into the charging point, so it might be possible that our battery should be a blast or that should be overcharge and after some time our battery should be a damage. So energy we can control everything should be the artificial intelligence. So now we are talking about the what type of the level of the vehicle system. So we can divide it into the 5 type of the vehicle system. The first system that will be a manual system. We are talking about the only in India. So in India we are dividing into the 5 different type of the level into the vehicle system. First, that will be a fully manual system. There is no automations is there. There is no any sensors, there is no any camera or anything that will be available. So we are talking about the 90s or the 2000 of the car. They are still in on the road, but we are taken care of these things, and they are traveling on the particular road. So that will be a manual car. Second, that will be a partially automation. So automation in the into the multiple way, like our remote control door locking system. We can through the Wi-Fi we can or we can using the remote control we can open and close the door. We can control the steering lock. We can control, but we are not driving the particular steering using the particular this way. But that will be a partially automation. We can there will be some of the indication. Our fuel indicator is there. Either fuel is empty or not. Our basic level, what is the current level of our fuel or the oil level. So we can, that will be a partially automations. We can divide it into this particular category. The level 3, that will be a conditional automation is there. The vehicle can control automatically, but the driver may need to take over. It means that right now you can see that will be a gear type of the vehicle is available on the road, but human intervention is required. There is no any gear mechanisms. You can do the accelerator. The vehicle will be a travel. Automation is partial automation is there, right? But still we need a driver to control the steering, to go take the decisions where we have to put the accelerator, where we have to put the brakes and everything. So for the decision making, the human intervention is there. The fourth level, that will be highly automation. So in this particular way, we are included the high tech technology. The GPS system is there, the high tech sensor is there, high tech lidar sensors for the front end camera, back end camera, to measure the distance between the two vehicles. The communication point is there, the automation is there, the geo fence is there. That will be a more important. For we are talking for an example, we are talking about the school bus. So in this particular school bus, they have a fixed path. You have to travel in this particular path and you have to travel in this particular speed. If the speed that will be over or it can be a over speeding, it can give the indication at the remote places or the school area. Now this particular vehicle number of the this particular bus is driving with the overspeed, or the rough driving is there. Or we can talk about the geofencing, the boundary we can fix it. You have to travel in this particular way, just like a Ola and Uber. The path is fixed. If you are reroute the path, it can automatically redirect it. But in this particular case, if the path will be redirected, it can give the indication to the particular remote area. Your vehicle should be travel along the wrong directions. Right? So this type of the high level automations we can include in this particular vehicle. The third, that will be a fully automations vehicle, or we can say that will be a driverless car, or fully automation driverless car we can consider in this particular area. So in India, we can divide it into the vehicle into this particular 5 categories. Now in the later on the slide, we are talking about the how we can include this type of the autonomy into our electric vehicle or into the normal vehicle. So basically, this will be the what is the role of the sensor into the autonomous vehicle. First, that will be a camera, high resolution camera. That will be a most crucial part of the selections into this particular. If we are talking about the automation into the EV or any particular vehicle, the vision sensors. We are talking about the vision sensor as a camera. If our camera is not high resolutions, it cannot categorize, it cannot detect the particular object. Because if we are talking about the automations car, it should be categorize each vehicle in front of you. That will be a two-wheeler, four-wheeler, or the three-wheeler. Into the four-wheeler, that will be a heavy duty vehicle is there, like a bus, truck, or any other heavy vehicle is there, or the small vehicle is there, just like a car or the similar type of the object. It should be a two-wheeler, bicycle, car, or there. it should be measure the object like a traffic signal, as well as the human is on the road, animal is on the road. So it should be clearly, it should be a measure as well as the categorize particular object. Similar, if we are talking about the high-tech level of the car, should be a driver taken the decisions automatically. Okay, what is the distance between the two vehicle? The traffic signal is the green or red, right? We should have to overtake the vehicle or not. Right now, we are taking the decisions manually, whether we have to overtake the vehicle or not. If the what should be the distance, or if we are talking, if we are overtaking the particular path, so what are the possibility for the accident? Because it might be possible ki in across the side ki vehicle should be traveling in the opposite direction, so it might be possible ki there will be a chances of the accident. So what should be the speed accordingly? What speed we have to travel, how we have to cross the lane, so it should be measured through the sensors only. But these sensors cannot be work into the some type of the particular weather or the environment and environmental condition, because that should not be in our hand. If the foggy weather is there, so camera cannot detect the or cannot be identify the objects in the night vision. So if we are not selecting the proper camera, it cannot detect the particular objects. So glare is there, focus is there, night vision is there, weather is condition is there. The weather, it means foggy weather is there, rainy season is there. So that parameters will be a play the some important role into this particular autonomous electric vehicle. So what type of the vehicle, what type of the sensors is available? So what we are doing, we are clubbing the multiple sensors together. If any of the particular sensor is fail, the second sensor will work accordingly. So that will be a four type of the in the navigations. We are talking about the navigations. If we are navigating to the electric vehicle, so there will be a four type of the technology is available ki how we can navigate from one place to the another place. First, that will be a lidar sensor. So in this lidar sensor, it can detect the 4 meter or the 12 meter of the range. If any of the object, it might be possible, it cannot identify or it cannot be categorized ki there is a vehicle or the whatever the object is, it cannot be categorized the particular objects. Lidar can sense the data ki some objects are into the particular path, and based on that it can give the indications based on the mapping system, and accordingly we have to take the decisions. This particular technology, so that will be a more expensive. So what we are doing, we are implementing the radar system, but radar system, whatever the frequency is there, so large antenna we have to develop, right? So this particular technology, it might be possible we can include, but this particular system cannot be work on the, it will be also dependent because some of the weather system is affected in this particular technology. It cannot be work into the particular speeding type because it cannot be measure the speed of the vehicle, but it can be a work on the rainy season as well as the foggy system, which the lidar system cannot be a work. So you can overcome the drawback of the lidar system using the radar. Third, that will be IMU. IMU is inbuilt in your electric vehicle. So it can measure the your current speed of the vehicle. It can measure the what is the current positions of your vehicle, where it is situated, what is the speed, right? And it can overcome the particular problem of the satellite system, because the satellite can transmit the signal, but it can be also affected by the weather system, because if the weather that will be a rainy, so it cannot transmit the signal on the proper time. So the GPS signal, when the GPS signal is not available, at that time we are taken the data from the IMU. So based on that, the portion of the sensor system is most crucial part into the automations, and we have to taken care about which type of the or which hybrid combination we have to use, because we cannot implement all the system into our vehicle. We can combine the two technology, or we can combine at least three technology, but we are not developing all the four system in our vehicle. Okay, so how the particular elect or the autonomous vehicle can be a travel. So initially we have talking about the particular sensors. It can be how it can detect the external environment. Based on that, it can transmit the data to our AI algorithm. It can be a processing. It can transmit the command to our particular actuator. In the actuator, we are talking about the steering as well as the vehicle. And based on that, it can take the decision and can transmit the command to the particular actuators, and based on that your automations or the fully automation electric vehicle can be a travel. Now we are going into the next step, that will be a how or what type of the AI algorithm we have to implement it, how we can implement this particular thing into our vehicle, what type of the algorithms we have to include. Okay, so right now we are talking about the what is the role of the artificial intelligence in our automations electric vehicle. Now we are comparing the two type. Assume that that will be a current vehicle. We are manually, we are doing that. Everything should be a manually. Our eyes should be work as a camera. It can sense or it can measure the particular objects. Our brain should be work as an artificial intelligence, because our brain can take the decisions whether we have to overtake, whether we have to accelerate, whether we have to brake, right? And based on that, we have to transmit our command to our hand as well as the leg, to our steering as well as our accelerator as well as our brake system. Similarly, we can include in automations using the camera or the radar system. We can detect external environment. Our AI processor, we can transmit the command to them. AI algorithm can process everything, and it should be transmit the command to the actuators. So in this particular way, we are doing our or travel our autonomous vehicle. Okay. So now we are already explained this already slide into the previous way, but most important task is that key perception is most important. Now our sensor part, what is around me and where are the obstacles, how far the obstacle, right? So that will be a multiple parameters. We are talking about the what is around me. So what are the nearby vehicles are available in our vehicles? Is there any obstacle in our path or not? We have to detect the lane as well. We have to detect the lane, whether it should be over speeding or not, or we have to overtake or not, right? So now we are going into the live demonstrations. We are talking about the three demonstrations. First demonstration, that will be a counting of the car. So there will be a basic example, not real time of the example. We have predefined loaded image. We have to give given our algorithm, and based on that, it can counting the vehicle. What are the vehicle are available into the road? Similarly, it can be work in the real time as well if we are mounting into our particular system. Second demonstrations, that will be a vehicle as well as the animal, right? We cannot identify because we are talking about the Indian roads. On our Indian roads, we have animals on the road, right? So it should be identify where is the what are the vehicles and what are the animals. And the third demo, that will be a traffic signal, because we have to on the red signal we have to stop, on the green signal we have to go forward, right? Okay. So just I am using the Google Colab. I think my screen is visible. Okay, so I have some preloaded examples I have. Uh, First, that will be a counting of the vehicle. Okay. So in this case, what we are doing, screen is visible.
Yes, sir, it's visible.
Okay. So we have done the Python coding. Assume that will be a AI coding which is already available into our controller. So here we have a preloaded image, right? So you can just change in this particular line. That will be a real time of the camera. In the real time camera, it can take the real time images in front of the camera. What are the images is there, and based on that, based on this particular images, it can detect the, or it can identify, or it can take the decisions. Because the video, that will be a frame by frame, right? It's the combination of the multiple images which can be running on the fraction of the second, so which cannot be identified, and we can be seen as a video. So here we have a preloaded deep learning algorithm, which is the sub part of the AI algorithm. So you can see here in this we have read the images. So here we are running the code. So it will asking me the data. It will take some time for the running the algorithm. Okay. Now here you can see it asking me to upload the image. So I'm uploading the image. So similarly, it can counting the number of the vehicle, how many vehicles are in front of our camera. So you can see here, it can detect the car, because this particular algorithm is trained for to detect the only car. It can detect the number of the whatever the car or the number of the vehicle. It can give me only the count, not the bifurcations. That will be a car, that will be a particular two-wheeler, that will be a bus, that will be auto, that will be animal, right? So this type of the algorithm we are already implemented in our electric vehicle. So it can counting whatever the car is there. So based on that, we can also control our traffic. In the first slide, we have already we have told that key mobility is not about the electric vehicle. It also about the smart city. We have to control our system smartly. So where the traffic, the number of the vehicle or the heavy traffic is there, we can control our traffic signal should be rate to the grid, right? So there will be a one separate paper we have already published just 2 months back. We are talking now. We are moving on the next example. That will be, it can identify the number of the vehicle as well as the animal. So same type of the algorithms. Here we have already predefined algorithm we are identify that should be, if you are running the board in the later on the slide, we are give you the example key how we have to train the model, how we have to train our AI model. Right now, this particular algorithm can identify the only this four vehicle: car, motorcycle, bus, as well as the truck. Pedestal on the person, it can be detected, and into the animal, it can also detect. It can only detect the cow, dog, horse, and sheep, not more than that. Because our algorithm, we have a predefined algorithm, right? But in the real time, that will be a multiple or any of the vehicle, any of the animals should be on the road. So that will be we have to train our algorithm in such a way that it can detect every vehicle, every animal. I think that will be error. I think the code is not working. Okay, not an issue. We can move on the next algorithm, that will be a traffic signal detections. Okay. So we have uploaded the image. That will be a one traffic signal is that it can detect what is the current indicator is that. It can indicate there will be a red light, so we have to stop. If it should be it should be for an example, it should be a green. So it can give the indications. You can drive whatever the indications you have mentioned in your programming. Move forward or go ahead or go whatever. So it can give the particular indication is that, right? So there will be a three real-time examples, but that will be a preloaded images. Okay. So into the next, the sensor fusion using the AI. Initially, we have already talked about the any single sensors cannot be work individually because there is some of the error in the individual, or there will be some of the limitation into the particular sensors. So we have to combine the two sensors, and technically we are calling as a sensor fusion because multiple technology we are integrating into our system, right? Okay. So what are the deep learning algorithm, or we can talk about the what are the artificial intelligence algorithm are available right now. So there will be a CNN algorithm, YOLO algorithm, and the transformer algorithm. But widely we are using the YOLO algorithm because it can give the real-time detections, right? It can be the speed is more because it can be compatible with our real-time controllers. The remaining two are working on the fixed GPU, fixed RAM. So the perception is there, but there will be also limitation of our algorithm is that it can be detected as a false detections. For an example, there will be a you can see we can compare with the uh, traffic line. So that will be some dotted line is there. But assume that key some of the similar type of the objects are already on our road. So it can be misunderstand or the misdetection is that it can detect that will be it might be a pedestal or it might be some of the other vehicle is that misdetections as well as the environment condition is also affected. So our perception is wrong, then our whole algorithm will be falling into the wrong way. So there is only in the autonomous vehicle. In the we have already mentioned you that key sensor, but it can also detect only identify the current object in front of the camera, but it cannot be detected the taken the decisions where we have to go. What are the current status of our own? Where is I am right now, right? So for that, there will be a separate AI algorithm is there. How we can measure our current positions? We can take the data from the IMU, or we can take the data from the satellite, or we can call it as the GNSS Global Navigation Satellite System. Through the satellite, or we can generally widely we are well known about the GPS system. Based on the GPS, they are identify our current locations. So this the particular way we are identifying our current actual positions where right now we are. Another that will be internal algorithm based on the IMU. We can apply the SLAM algorithm for the navigation purpose. The simulations, localization, and mapping. It can detect the current location as well as it can map what are the paths we have to fix it. But in the basic, you can see in the two figure that will be a sensors that will be only SLAM algorithm for the navigations. In the second figure, we have implemented the deep learning algorithm with the SLAM. So SLAM can detect where we have to go, where we right now, and we are applying our deep learning algorithm, how we have to move, where we have to move. We have to move, we have to control the speed, we have to slow down the speed, whatever that will be a decision taken by the artificial intelligence, or we can call as the machine learning, whatever the algorithm we can implement it. Based on that, we can take the decisions, see how or where we have to move. Okay. So there will be also challenges. We are talking about the India. There will be a mixed type of the traffic. We are not parking our vehicle into the particular whatever the rules are there. There will be some service road is there. We are, if the traffic is closed, we are parking. We are staying into the service road when the signal is green. Then we are suddenly traveling from the service road to the main road. We have a mixed type of the traffic. The two-wheeler is on the road, three-wheeler is on the road, four-wheeler is on the road, heavy vehicle is on the road. In Indian conditions, if we are talking about animal as well as the human are also traveling into the road, right? We are also violating the signal. If the signal is red, then also we are traveling. But automations, we have to take the particular decisions because we don't know, because mixed type of the traffic, it means that some vehicles are non-automation, some vehicles are automations. We can also combine in this. The automation vehicle are strictly follow the traffic rules, but manual vehicle, if they are not following the traffic rules, then it will be also chances it will be accident, right? Informal lanes, we are traveling into the wrong side as well, right? So we have to train the model in our own country, because whatever the algorithm is available, that will be trained into the external or the other country. But on our conditions, we have to train our own model. So how we have to train the model? We have taken the data set. That will be some of the picturized, but here you can see that will be a drone, but it should be your own particular vehicle which you have to train. Which will be the combination data set? It means that the number of the figures or number of the images, it should be your traffic signal, it should be a various type of the photograph of your vehicle, number of the animals which are moving or roaming around the roads, the how the humans are traveling, the picture or the figure of the humans, as well as the whatever the large data set you have, your AI algorithm should be trained accordingly. अब जितना डेटा सेट उसको देना चाहते हो ना, वो एक सिंपल सा एग्जांपल ले लेते हैं, चैट जीपीटी. If you are asking the more questions or more prompt, it can give the accurate out. The similar way, you have to wider data set, your accuracy is more. Then you have to decide it, you have to 70-30%, 60-40%, 80-20%, what or how you can test your model. 90% is in the 90% of the researchers are using the standard method, that will be 70-30, but rest 10 of the researchers are using the 80-20. The 80% data set they are used for the training purpose, while the 20% data they are using for the training purpose. Right? Weight file you have to decide it based on the human. every researcher are define the different weight size. Based on that, your model should be a train. It should be approximately zero point 0.9, above zero point 0.9, the 90% and above, you have to with the weightage 5. And based on that, your model should be a train and it can detect the object. Whether the human are there, whether the pedestal is there, whether what is that particular exactly traffic sign is there, right? Now we have sense, we have taken the data from the sensors part, we have implemented our own algorithm where we have to move, right? Now we are talking about the decision part. Okay, how we have to move. So in the previous slide, we have already informed you that that will be a depend on the user to user, that will be a dependent. 70-30, 80-20, 90-10. So user to users, the training of the algorithm is a different. You can see in the two figure that will be a 70-30 and that will be a 60-40. You can detect your car has been detected if the human are already on the road. So 70% are saying that you have to stop, or the 30% are saying that you have to cross the line, or you have to traveling accordingly. It cannot be affected to the human, or the human cannot be injured, right? In the second figure, you can see that that will be a two vehicle are crossing to each other, but they are not crossing to the particular lane. You can see the white vehicle are not moving on the particular way of the red, or we can assume that red vehicle are traveling into the wrong side, right? So 60% are assuming that we have to move forward, while the 40% are decision is that we have to cut, or we have to overspeeding, or we have to overtaking the particular vehicle, right? So it should be vary from various person to person is that. So based on that, you have to take the decisions. What if this particular case study or this particular case is in front of your algorithm, what you have to train or what you have to take the decisions, right? Okay. Now we are talking about the PID controller. That will be the preloaded images, your how to control your vehicle, how to steering or how to move your steering. Again, we are moving to the Google column. That will be a widely we are using for the training purpose, not into the real time, because the real time we have to use the real time camera as well as the microprocessor and the controller. 90% cases we are using the Jetson Nano or the Raspberry Pi, but that will be a preloaded images. So you can see here what are the algorithm it can take the execution time. That will be more than 30 or 50 seconds. So your processors or your AI algorithm should be much powerful. So based on that, it can take the decisions, right? So assume that what are the vehicle position is that based on that you have to take the decisions whether you have to cross the lane or not to cross the lane. And based on that, you can send the command to your steering how to move. You can see here that will be a vehicle is that. So they are crossing the line. So based on that, you are controlling your steering. How speed you have to you have to cut or you have to overtake, and smoothly you are traveling in your smooth way. तो जैसे हम वर्कआउट करते हैं ना, जैसे ही कुछ सामने व्हीकल देखा हमने ओवरटेक कर लिया, सडनली हमारी स्पीड इंक्रीज हो जाती है, वी आर ओवरटेकिंग द व्हीकल, देन वी आर ट्रैवलिंग इनटू द नॉर्मल वे. So in this way, we are controlling our PID controller, or we have to train our PID, which can control the steering. Right? Okay. So most of the time, we have to also taken care of the AI is safe or not, because it can take the decision by themselves. But might be possible if your AI algorithm is not properly trained, it might be possible it can be a chances of the fallen down. So AI algorithm, what the AI algorithm is do, they are all whatever the you have to train. So they are following the rules only. If someone are breaking the rules, but your vehicle should follow the same rules which you have already implemented, right? Safety monitoring, we can also measure the thing, the similar type, they are, because we have already discussed in the previous slide, that will be a mixing type of the traffic in on the road. Some vehicle are autonomous, some vehicle are non-autonomous, right? So safety is more important, whether and how fast they have to take the decisions. Suddenly object is there, it might be possible it will take some time to take the decisions, and based on that it can take the actions, right? So safety monitoring is also there. Sometimes it cannot be a work, right? Because of AI algorithm, you can see when we have run our code, it will take some time. There will be a 15-second or the 20-second, but that will be a more crucial time when we are talking about the automations vehicle. If we are traveling about the more than 70 or 60 kilometer of hour, 60 kilometer per hour speed, so that will be fraction of the second. That will be most important. So energy part, how the energy, what are the route selection is there, just like a GPS system. If we have mentioned the source as well as the destinations, and accordingly can travel, but accordingly, so when you are deciding the task, if is there will be a lot of the traffic in this particular area, and this route is a long, but there is no traffic, but also battery management is also more powerful, the fuel efficiency is more powerful. Your battery is sufficient or not, we can travel in the long duration, even though there is no traffic, but the traveling or the distance is, we have to travel more, right? So this will be also more important, how we have to decide. This will be also discussed in the multiple time in the previous slide. Vehicle to vehicle, vehicle to infrastructure, so we have to communicate it. Interconnections, coordination is also more important. uh, right now, what are the challenges we are facing? First, that will be the data bias, because country to country, the traffic rules are different, the traffics are different. So our model should be trained accordingly. In our India, we have a right hand side driving seat. In the other country, they have a left hand side driving seat, right? The country to country, the traffic rules are different. Rarely even. Some time of the event, like just like a marathon, the traffic is ongoing, some rally is also moving on the same particular road. So at that time, what we have to do? The automations, we have to work accordingly. Ethical decisions. Sometimes what we are doing, if suddenly we have to take some of the decisions. If suddenly we animal or the, if we are for an example, if we are traveling into the 30 kilometer or 40 kilometer of the speed, suddenly small kid are in front of our car, what we are decided, we are, as a human, we are trying to save the kids. Otherwise what we are doing, we are driving into the wrong directions. It might be possible we also injured ourselves, our vehicle should be a damage, but we can save the kid, right? So some type of ethical decisions, AI cannot be take the decision in the particular way. Legal responsibility, we are implemented the AI, but assume that key, it might be a chance if accident will be happen, who is the responsible? Company who has developed the car, company car owner who has traveling the car. So legal responsibility we have to take care. This particular happen, particular we are talking about the Indian cultures only. The scene in the figure, the animal is on the road, right? Okay. Some of the global study, what are the current e-vehicles are into the market. The Tesla has launched the e-vehicle. Waymo has launched the e-vehicle. BYD also launched the e-vehicle. But all the company has the same target. They have to save the fuels. They have to travel the long distance. They have to do the automations, right? But the technology should be a different. It might be possible that technology should be a different. The Tesla has camera-based automations, while the Mimo, Waymo and the BYD are using the lidar plus radar system, right? So different technologies they are using, but their goal should be fixed. They have to make that their car automations. They have to travel the more long distance, single charging unit. They have to speed up to the 70-80 kilometers per hours, and they have to save the fuel, right? Okay. What the Indian initiative into the EV sectors? Smart city missions. Right now, we are developing the smart cities. We are developing the multiple sensor into the cities so we can interact our infrastructure to the vehicle. We are launching the few scheme for the that will be some different manner. We are not talking about that particular way. Some e-vehicle we have provide the subsidies. We are providing the some scheme government has launched some of the scheme. The most important part, GNSS satellite navigation. Right now, we all are using the GPS system for the navigations, but GPS cannot be well or cannot be give the proper data if we are in our country is a developing country. GPS system cannot be detect where the construction is there. What are the what country is developing, where the construction is ongoing, where the urban area is. If we are talking about the urban area, so some development are there. But India has launched their own satellite, so we are moving to the Navig, GPS to the Navig. EV charging. So right now, initially 1 year or 2 years before, we are seeing that there will be a 5 kilometer distance here, only one charging station. Right now, you can see in the 1 kilometer radius, there will be a 3 or 4 charging stations, right? So India has take some of the initiative into the EV sectors as well as the automations into the EV sectors, right? Right now, the electric bus are already available, two-wheelers is already available, electric four-wheeler is also available, right? We are also developing our country into the smart traffic signal. If you are not wearing the helmet, but that will be a separate topic. I have already taken some of the real-time example, which we are right now on working on that, but there will be a time constraint. Uh, so based on the heavy traffic, we can control the traffic signal. Based on the traffic signal is more smarter if you have not wear the helmet, right? Even though you're if you are traveling into the electric vehicle, it can give the e-memo. If you are not wearing the seat belt, it will also give you the e-memo, right? So these are the system we are also developing using the AI and ML algorithm. Even though your vehicle should be properly in the working condition, your even though right now what we are India is doing that your e-vehicle data that will be a service to service, that will be a charging or not, you have maintained your vehicle or not, right? So that particular data is transmit to the particular data center, and based on that, it can give you the some of right now the pollution control, the traffic in the, if you traffic police are taking your pollution PUC card, whether your vehicle that will be in the as per the laws or not. It can be a it cannot give the more transmit the more pollution into the environment, right? So we are developing the smart infrastructure as well. So what are the research opportunity we can handle it? Uh, if you are working on the battery health monitoring system, sensor integration, we can talking about the fusion of the sensors, multiple sensor into your system. You can develop the AI and algorithm. You can smarter, or you can implement your algorithm in a smarter way or the more accurate. Vehicle to the X protocol. Right now we are talking about or we are not transmitting the data up to the 1 kilometer radius, but we can transmit the data to the longer distance, right? EV charging stations, because right now, if we are developing all the electric vehicle, so sufficient electric charging station is there. We are not into the queue or the fast charging stations. Within a 1 minute, within a 5 minute, your vehicle should be a charge. Right now, whatever the time, 10 minutes, 15 minutes, 20 minutes are taking the charge, or they are taking the some time to charge the 100% charging our vehicle. But if assume that there will be 100 vehicles are into the market and all are the electric vehicles, and we have only one electric stations to the nearby. So our charging station should be a fast charging, right? So this will be a research opportunity. Right now we are lag behind in this particular area. So uh, we can improve or we can develop something new things in this particular directions. I think, oh sorry, smart mobility. So the particular topic is not about the smart mobility. We are not talking about the AI, but we have to implement the AI, but safer mode, cleaner mode, and the more efficient mode. Because AI is there, but right now they are not particular safer, they are not particular more efficient. Right now we are developing that will be a 70 to 80% of the accuracy, but we have to achieve at least 95 to 98 percentage, so we can replace our old vehicle to the EV vehicle as well as the automations, right? So if you have any questions, you can ask. Hello.
Participant, any question? Please unmute the mic and please ask the question.
Hello, sir.
Yeah.
I have got some questions. From which website you have taken the data for training and testing, sir? For counting the number of cars, vehicle, and animals, traffic signal, etc.
Okay. Ma'am, actually, that will be a predefined algorithms we have right now. We have taken, but what you are doing that key, some of the ready-made database is already available. You can use the manually, you can use the RoboFlow, but you have to take your own data set because real-time traffic or because what we can say that key, whatever the data set that will be in the past. It will
Yes,
be
sir.
a 1 month older or 1 or 6 month older data set. Right now, you have to, if you are developing your algorithm in the current way, so you have to take in the data set of the 1 week, not more than the 1 week older, because you cannot see that key in the 6 months the construction is developing. The traffic signal is changed, whatever the traffic rules are there, the traffic lane is already developed. So you have to make your own data set by clicking your pictures. So you can use the old data set as well as you have to taken your or you have to create your own data set. You can mix up it and you can train your algorithm.
Right, sir. Have you done that, sir?
Yes, ma'am. Actually, I have done, but not into the electric vehicle. I have trained my model on the particular drone technology. We have taken the some of the data set into the particular flow as well as this particular way. 1 minute, I can show you the one video. I think what right now we are working on that. One student has working on that. They have also taken this data set on the RoboFlow as well as they have create their own data set.
Okay, sir.
In the
Okay.
traffic signal, we have taken the separate permission from the traffic police and we have captured some of the video and framing them and we have created our own data set.
As on today, what is the performance that you have obtained, sir, for algorithms like CNN, YOLO, and Transformer?
Ma'am, actually on the CNN, we have approximately 84 to 85%, but in the YOLO algorithm, we have take the accuracy about the 93, 94%.
Okay, sir. YOLO, which version you have taken, sir? Up to YOLO 11, it has been developed already. But
Yeah,
which YOLO version it has been tested for your application?
Okay. And we have worked on the two models that will be YOLO V8 as well as the YOLO V10. So
Okay,
in both
okay.
models, we have worked on that and we have get the accuracy about the 93 to 94% on the YOLO V8 on the YOLO V10, we have get the accuracy about the 91%. We have not tried
So,
the YOLO.
okay, sir. It is on only still images?
No, ma'am, we have taken the data set about the 20,000 images or the 23,000 images.
Then video, is it been tested on video, sir?
Yeah, ma'am. But on the pilot model, not in the real time. Right now, we are working on the pilot model. We are not successfully implemented in the actual implementations. Is that right now we are in the pilot stage? We have taken the system on our college premises, and we are taking the data, and we are control, or we are take the decisions whether that system will be work or not. If once it will be, we have tested successfully, then we are implementing into the real time.
Okay, sir. Thank you. So what is IMU system, sir?
Internal measurement unit. So inside the vehicle, what are the current accelerators? Just we can talk about if you are using your Google map, if you are traveling to one place to another place. So it can also indicate the speed, right? Because in your mobile phone, there will be accelerometer. So based on that, it can measure your speed. So similarly, it can measure the internal measurement unit. So inside the car, so that will be unit is there. So based on that, it can detect the current speed of the vehicle, current positions, current magnetometer. So based on the three axes, it can detect the particular multiple parameters. You can measure your current locations where right now your heading angle, key right now in the which directions you are traveling, as well as your current speed.
Last question, sir. BMS chips all are available as on today?
BMS chip is available on the today. Right now, the IIT Madras is developing. They already developed the large BMS system is there. So right now, not in India, but we are importing from the other country. But recently, 1 year or 1.5 years back, the IIT Madras is developing the BMS system. Right now, we are working on the e-vehicle that we are developing the racing car. It might be possible your college is also participating in the Formula Bharat event, but we are also participating, but into electric vehicle. We are also talk with the IIT Madras. They will provide the BMS system for us.
Okay, sir. So what is level 4 robotaxi?
Level 4 robotaxi, that will be automation. Automation level I have already explained in the previous slide. There will be a 5 level of the automation. That will be not a fully automation. Some type of the human interaction is there.
Okay, okay. Thank you, sir. Thank you very much for your nice answers.
Thank you, sir.
Okay. Thank you, sir. Sir, should I leave?
1 minute, sir. Mogdum, sir.
Hello.
Dear Padil sir, you can continue, sir.
Hello, sir. Yes, sir. Yes, sir. Yes, sir. So, thank you, sir, for such a nice and wonderful session. I'm here for vote of thanks. I would like to express sincere gratitude to Mr. Raj Hakani, sir, for delivering an enlightening session on autonomous and connected electric vehicles and the role of AI in it. So, his expertise made this session really insightful. Also, I would like to thank our HOD sir and the organizing committee for arranging this valuable FDP session and all the participants for their active engagement. So after this, the next session will start within a few minutes. Stay tuned. Thank you.
Thank you, Raj,
Mr. Raj,
sir.
sir. Thank you very much, sir.
Thank you, sir.
Hello. Shweta madam also present.